Alright, welcome to my 4x8 test bed. It's still a mess. Pre-COVID, in this area, if you look at my other videos, I had all my O gauge. It was 11 foot by 6 foot 6 inch. I was pre-COVID, I was going to move, sell my house, and then I was going to get a bigger basement, all that stuff. Well, COVID made house prices stupid, so everything's been packed away. I said, you know what? I have all these HOs. I can do a 4x8 and screw around. That's why it's a mess. It's a screw around setup. So it's 2 outer loops with a figure 8 in the center. And this video is kind of to show, video is more for me. And what I mean by that is I drew this up and wanted to get it working. And Corey, thank you very much. I bought all these switches and I was trying to figure out how to wire them. And he said, why don't you use an Arduino? And I said, okay. Well, there's a Arduino Uno. Underneath this table, I actually have 2 megas, one tied to a 16 channel relay pack, which is going to drive the snap track. And I have another mega with a shield with a Wi-Fi board for DCC++EX. So this video is for me because if I tear it apart, I'll forget how I did it. And then I'm always trying to remember. And I figured, you know what, maybe this will help somebody else understand. So, sorry, my finger. I'm trying to hold my cell phone while doing this. All right, let's zoom in here. So, here is, obviously, an Atlas switcher. This one I think is broken, as you see, but you'll still get to see the point. Now, the center pin here is ground. If you were to put ground and voltage here, it'll snap one way. Ground, you throw voltage this way, it'll snap the opposite direction. So, you can do the same thing with relays, as I have here. Now, each one of these are going to require 2 relays. Every relay, there's single relays, there's 2 relay boards. This is an 8, and as I said, I have a 16 underneath the table. Now, the relay boards require very basic. I'll show you over here. Over here is ground, and over here is 5 volts from the Uno. Okay, and those pins are over here. If you look down there, it'll be let's see. Lighting's not the best. I have 5 volts and ground. Okay, now this is, if you look at the relays, they are, as you see right there, find my pointer here, my screwdriver, they are 5 volts. My underneath the table, the 16 channel is a 12 volt. All that means is an Uno or Mega is not enough to drive it from that 5 volt pin. Okay, so with that, I actually have a PC power supply, 12 volt going into it to power it. Now, these relays, if you Google it and you research it, there's other people that have done different things with these. You can send 120 volts AC through it and control light bulbs. So the 5 volts is more so for the board and to control the relays, but the power they send through it is a lot higher. But then the point of this video is to show you something different that I always forget. Okay, so we're going to look at this one relay right here. Okay, on this side, this is normally closed. The center is where you're going to put power. And over here is normally open. So think about it. If you were to put a wire here and run it to, say, a light bulb, as soon as you power this unit on, it's normally closed, meaning it's going to jump through the circuit and the light bulb will be on, switch or not. Then when you throw the switch, it'll turn it off. So for these snap switches, they have to be momentary. If you just throw a switch and throw it, you're going to fry it. The coil inside is going to get hot. So you go from power to the center, over here to normally open. And what I'm doing is using JMRI to control the relay to say, tap it closed, and it throws the signal through, and it comes over and shorts these 2, taps it, and it will throw it one way. Now, JMRI, I have the same setup as you notice. I'm skipping the normally closed. I'm going to power here. And then the normally open is looping back. Actually, I'm sorry. So I'm trying to keep it color coded correctly, so I followed it wrong. So this wire here, these two wires here are my power coming in, okay? And I'm actually pulling the power from an old Tech 2, red and white over here, tied to power, and I have ground over here, okay? And then, as I said, they come over here. Now, you don't have to do it this way. I actually realized underneath, you could literally take every middle pin of each relay and jump them. You can go here, 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 and so on down the line, and just jump them straight across, 5 volts. For what I'm doing, which I'll show you in a second, 5 volts wasn't enough. I had to go to 12 volts underneath with my other board. For my demonstration, this is going to work fine for what we're doing here. Okay? Now, recap. I'm taking voltage here. As you follow the wire, the long wire, it loops around, and it comes in to give power to this post and this post. And like I said, this could have been a single wire that I just jumped from red to where the white is and didn't need the wire to go back. Okay? Lesson learned. Anyway, there's my 2 power. When I go to throw the switch, it's going to do either this one or this one, and then it's going to throw that like this. Now, for the Uno itself, I'm also using these pins. I use the voltmeter. 40% throttle is 5 volts. Here's my voltmeter. So I did that so I didn't burn out the Uno. Okay? Now, the Uno itself, obviously wires are jumping from the Uno to the relay board. We already said this one was ground, this one was voltage. Now, this is right here is relay 1, pin 2, pin 3, pin 4. So it's relay 1, 2, 3, 4. Okay? Now we come back over here, we need outputs. And if we look, when we look at the sketch, we'll actually get it correctly, but I believe that's 3, 4, 5, and 6 are being used. No, actually 5, 6, 7, and 8. Okay? So 5, 6, 7, 8. Now, we come over here. All right. Now, I'm horrible at code. I found this code online. I was able to work with it, figure it out, and what to change, what to modify. So, as you see, include CMRI.h, include auto485.h, and then defining, and then integer T1C is equal to 5, T1T is 6, T2C is 7, T2T is 8. Now, if I wanted to control more relays, I just keep going with it. Now, somebody did something the other day. I saw they did arrays. I'm not good with coding to begin with, so arrays would be awesome, but for now, the code is just going to be long and a mess for me. If I wanted to control another snap switch, I would do integer T3C equals 9, and integer T3T is equal to 10. Okay, that would be another step. But if you look down here, now we have integer T1 underscore bit underscore close, throw, and a close and throw for T2. Auto 485. All right. And then we come down, void setup, pin mode. Here we go. T1C output. Okay. T1T output. Digital write, T1C high. Digital write, T1T high. Okay, so we see the code here. I'm going to scroll down. Bus begin 9600. Now the CMRI process for JMRI, T1 underscore bit underscore close. You see the command line there. Now this is where I really get lost, but get underscore bit 0 is equal to 1001, not 1000, and then get bit 1 is 1002. So for me to do another relay, it was T2 bit underscore close, get bit 2 is 1003. The //1001, 1002, that's all a comment. So it just put it in here just so you know what's going on. So if I wanted to add a third relay, like I said up top, all I would do is I would copy those two lines, T2-bit close, T2-bit throw, and I would do T3-bit close, T3-bit throw, and I would do get bit 4 and 5, and that would make it 1005 and 1006. And then you have to do the digital write line underneath as well. So now you write this out to your Arduino Uno or Mega, and that is good. Now let's go ahead and bring up JMRI. Alright, we're going to bring this up. Now the first thing that you need to do if you follow all the tutorials is you need to set up, let's see, go edit, preferences. Okay. So you would click the little plus button, and then you would do JMRI from here, serial, you choose your COM port, connection prefix is C, connection name JMRI. Now, one of the things, another reason I'm doing this video is because a lot of videos, they show it working, but they never say stuff. And then, like YouTube videos, I ask questions, and it took a while. One guy had to try and remember, and he remembered, he's like, oh, there was something about the baud rate. Well, I found it. When you come in here, normally, this looks like this. And I couldn't figure it out, right? When I came down here, I checked this off. That was actually 19,000, it was the other, it was a 19,200, okay? Bauds per second. And I had no communication, couldn't get JMRI to work. Once I changed this to 9,600 to match what's in the sketch, remember, let me pull up the sketch here. The sketch line was right there. Bus stop begin, 9,600. They need to match, they can communicate. Once I did that, my Uno, when I hit buttons, started to flash. The little lights on the Uno itself. I didn't have the relays hooked up yet. I was just trying to get communication going, right? So once you do this, you then have to come down and you have to hit save down here. And then it's going to restart on you. When it restarts, you will then have JMRI. You go to configure nodes. Okay. Now I have an entry here. I'm on cell phone. It's struggling today to focus, sorry. But anyway, you come down here to add node. You click add node. And at the top, this had -1. All I did was remove the negative. So it's a 1. That was something else I learned in all the tutorials I followed. It's something about, let's do it again. If we go back to the code, something, I think it's up higher. Let's take a quick peek. Right there, define JMRI address 1. I think that's the line. So if we did a -1 there, it probably would have worked, leaving it negative, but maybe remove the negative and it's a 1. All right. Now, once you do this, you will have a line here, address, bits per card, and all this stuff. You want to go back, so you say done, then you want to go back and you want to save it, okay? Now, we go to tools, tables, turnouts. Now I already have them defined here, okay? All you do is at the bottom, and it's really shaky, I don't have a mount or anything, so my apologies, but you click add. Now, at the top you give it a name. You can call it whatever you want, okay, under username. Under hardware address, this was what relay we want. Now, I did 1001. We already have a 1001. For this purpose, because I don't want it to burp on me, I'm going to do 1006, okay? Username, we'll call it left turn. We will say create. When you do this, it will ask you how many output bits. You want 2, okay, because we're going to control 2 relays with 1 button. So we say 2 bits. Now, if we choose that steady state output, it's going to lock the relay and fry our thing. So we're going to do pulsed output. There we go, right? Now we have it down here. And it's actually the one up called left turn at the top. Now, we don't have any relays set up there. When you first launch this, these are actually at an unknown state. So you got to click them and then click them, then they'll work. But, you hear that? All right, now I'm going to come up here and show you. And yeah, this thing is definitely not working. It's not throwing. I didn't see it move there. But at least over here for the lights, you'll see the functionality. If I do closed, see that was relay 2. If I click it again, that's relay 1. This first light here is relay 1, relay 2, relay 3, 4, 5, 6, 7, 8. So they have their own lights. Now we go over to the other relay. Okay. And see, that's 3, 4, 3, 4. Now, this guy isn't working, it's broken, but hold on, I have an idea. All right, let's see if my idea works. Okay, so I said the center pin is coming from voltage. Let's go over to, there we go, I got just leaning, the negative leaning on the ground. So 4.6 volts here, okay? Now, that's to this pin. And I told you this is normally open. So if I click over here, there's nothing. Now, let's see if I can figure out how I can balance this. All right, now let me try and throw it. See, the voltage jumped and dropped. Click it again. Voltage really didn't go because it wasn't supposed to be on that one. That relay 2 was this one. Okay, so now I'm on the white pin. We have voltage. We come over here, which is normally open. We have no voltage. Interesting, it says negative. Okay, whatever. But let's try this again. Let's see if I can hold this here, get that in there. In JMRI, I'm going to go down to my other button. Okay, this one is not jumping. Interesting. Yeah, like usual. Stuff doesn't always work as planned. I know for a fact, underneath this table, I have this set up this way. It could be anything. It could be these wires here, kind of loose. Well, actually, no, because the relays are tripping. So let's do this. Like I said, normally closed is on that first pin of the relay. So this is relay 2. This is the 4th pin, which is it's normally closed. We have voltage. And we have voltage on the middle, which is what we expect. And we jump to here. We have no voltage. And oh, no, hold on. I know exactly what I'm doing wrong. Sorry, my bad. There we go. See it pulse, pulse. So the relay is working. What I was doing wrong is in JMRI, I was choosing the other one. So remember, when you have one of these, that relay 1, that's a CT1001, you click it once, it's going to control this relay. You click it twice, it's going to control this relay. I actually was testing here, which you saw. I had voltage. Then I jumped over here to show you voltage, but I actually went to relay 2 instead of staying on relay 1. All right. So that's really it. Not that complicated. There's not much to it. I know it's 20 minutes of boringness. My apologies. But just as a quick recap, Uno, Mega, the biggest difference is in Mega, you can control a lot more. The Uno, you can control, I'm not sure, I have to look at how many outputs there are, but you can see 1 through, let's say, see 13. And on the inside, I see 1 through 13 and an analog AO through A5 for 6. I don't know if you can use them. So 13, right there, you can only do 6 times 2 is 12. So you can do 6 relays with this. On a Mega, you can do a lot more. There's like 64, I believe. So you can do 30 some relays, I think. So that's the difference why you'd want to use it, Uno or a Mega. Once again, USB power to the Uno, and then you take ground and 5 volts. If you have the any relay board that takes 5 volts, you can, from what I understand, this down here has a VCC jumper and a ground. You actually can put ground on one pin, and I'm not sure which the other one, but you can actually hook up an external 5-volt source to it if you want. But I'm driving it with the Uno, and it works fine for test bed. So once again, ground, 5 volts from the Uno to the outer 2 pins of the relay board. Just pay attention which one says GND and VCC. And then your inputs, 1 through 8 for each relay. Once you're done with that, a little bit of code, and you'll start driving the relays. Hopefully that will help you. I'll be able to look at this later when I want to connect it. So underneath on my 16 relay, what I'm going to do, I'm not going to have 2 separate powers coming in. I'm just going to jump to 1, and I'm going to create a jumper to the middle, and right down the line, and just keep hitting them. Because you're just giving constant power, and you're only tripping whatever relay you need. So, all right, hopefully that helps you.